Hi, this is a short tutorial on the shift register to help explain its operation. So on the top we have the shift register as you would appear in GX Developer. Okay, we can see the nomenclature used here for the shift register itself. We have the shift left function, and for the purpose of the tutorial we put in shift left, but shift left or shift right, either one operating in pretty much the same fashion for the purpose of this. And we have our source. So our data source for this particular one is x2. So whatever data is on the x2 input is what we're going to put into our register. The destination within the register, or the starting bit of the register, depending on how you want to look at it, is M0 in this case, which is the internal auxiliary relay M0. K8 indicates the size of the register. So in this instance, it is K8 is decimal 8, so it's an 8-bit register essentially. And the final piece then is the shift size, okay, or the how many bits the register shifts for each index pulse, okay, in this case K1. So we're going to move 1 bit for each register, okay. As you can see to the left here, our index is going to happen whenever X1 goes high, okay, so that is our pulse. Okay, and on the bottom, what we've done is we've just represented the shift register as the 8 different bits, and we can have a look at the content of each of the 8 bits. And this is purely for illustrative purposes. How it operates, we have to the right here, we just keep an eye on that information that we have, so our source, our destination, our register size, and our step size. Okay, so if we look at our source, and we'll begin with x1 in a low condition. Okay, so if the input x1 is low, and we get a high on x1, we'll get our index pulse over here, and our register will index one place as per the step size. We don't see anything happening here because that x2 is essentially a 0 that will be entered into the register, and all the other zeros in the register will be indexed one place to the right. Okay, for the illustration that we have here. The next scenario then would be if we have a high on the x2. So a high on the x2 is a 1 bit. Okay, if we get our index pulse, okay, which is the x1, this is the step to register. It will take that x2 high, which as I said is a 1 bit. Okay, and it takes it and it places it into M0, because M0 is our destination within the register for that first bit. Okay. When X1 goes low, okay, that 1 remains in M0. So that will be in M0 until it is cleared from the register or shifted along the register. Okay. From this point on, we'll look at X2 just remaining low. We're just going to look at that 1 bit that we've placed in and how it moves through the register. Okay. So on the next X1 high, that M01 will move into M1. Okay. On the next index, it moves to M2. Okay, and as you can see, it's moving one place. Each index pulse moves at one place. Okay, etc. From M2 to M3, M3 to M4 on the next pulse, M4 to M5 on the next pulse, M5 to M6 on the next pulse, and then M6 to M7. Okay, M7 being the last bit that we have in this register. So on the next pulse of X1, what will happen is that the bit that's in M7 will move out of the register, and we no longer count that bit, it just disappears. Okay, so on the next index, it moves out, disappears, and it is no longer relevant to us. Okay, so that's the standard operation of a shift register with a single step. Okay, what we really use the register for is to move those bits along, and at certain points along the register are represented within our production line or whatever. We want to take the information that's in the register and use it for something. Okay, so for this illustration that we have here, we can see that we've got a 1 already placed in the register, and it's at M3 within the register. Okay, and somewhere in our ladder program, we can see that the auxiliary coil M4, that we are using a normally open contact from that. Okay, and whenever that goes high, we are going to activate output Y1. Okay, so looking at the 1 that we have in M3, what's going to happen is we will get an index pulse, which is our X1 pulse. Okay, that will go high, and that will move the 1 from M3 into M4. when the 1 moves from M3 into M4. Because M4 is now high, it will close the normally open contact that is M4 here. And of course, when that contact closes, our Y1 will go high. Okay, we'll have an output on Y1. After the index pulse turns off, that 1 will remain in the M1 position and within our register until again it is removed from there by an index pulse again. Okay, so the next index pulse will take that M1, that 1 that is in the M4 position, and it will move it into the M5 position. Because M4 is now a 0, this normally open contact will reopen and our output will turn off. Okay, so that's how we use it to control an output. The next thing we can look at is how we can put some data into an individual bit within the register. Okay, so not necessarily inputting a bit onto the M0 point. Okay, so our ladder program up at the top here, we can see that if X3 is high, that makes M5 high. Okay, but M5 is part of our register here. Okay, so let's have a look at what happens. X3 goes high, M5 goes high. Okay, and that 1, that is that high M5 signal, is placed within the register, and because M5 is high, that is a 1. Okay, and that's sitting in the register. What happens next is we want to index our register, so that's X1 going high. So when X1 goes high, we index our register. We take that 1 that we've put in at M5 now, and that, like any other bit in the register, once we index, moves 1 place to the right into the M6. Okay, and then once X3 goes low, M5 goes low, the 0 that was in M4 goes into M5. Okay, and we can carry on with the register as per normal. We've just injected a high bit into the middle of the register. Okay, typically something that we would use that for would be inputting test results or check results into the register, into a point within the register. Okay. And the last thing we want to look at here is a slight variation on the registers we've looked at so far. So all of the registers we've looked at so far have a single step input or single step index. Okay, but this one here we can see that the last piece of data within the shift register in the GX developer software is K2 in this case. Okay, so K2 means a 2-step index. Okay, so in this case, if we take X1 to be high, our index pulse. Okay, sorry, before we start that, we're just going to put a 1 into M0. We're going to use that. Okay, we're not too worried about it getting in there. But if there's a 1 in M0, or we put it in from wherever, once we index X1, so we get our index pulse, what this does is it will shift from M0 in this case 2 bits, which will be up as far as M2. Okay, the next index pulse will shift from M2 to M4. The next index pulse will shift it from M4 again by 2 bits to M6. And then the final index pulse will index it from M6 out of the register where it just disappears. Okay, and we carry on as normal. Okay, so that's showing it as a 2-step register or 2-step index within the register. Hopefully that will help to clear up some of the issues and concerns you have with shift registers and help you forward with your assignment. Okay.